Did you know the world's longest mountain range is underwater? It's called the Mid-Ocean Ridge, stretching over 65,000 kilometers, longer than the distance around the Earth. Sounds like a hidden world, right? Well, beneath those waves, Earth is busy reinventing itself every day. Let's dive deep and explore the fascinating divergent plate boundaries, where our planet's crust slowly but powerfully pulls apart. Hi, this is Earth Diary. Let's take a quick peek at one of Earth's coolest spots, divergent plate boundaries. These are the places where the planet's crust is literally pulling apart, slowly creating brand new ground beneath the ocean. What's really wild is that beneath those waves, there are underwater mountain chains and even hot springs shooting minerals into the sea, supporting some of the weirdest creatures you can imagine, and all without a single ray of sunlight. If you enjoy breaking down big ideas in Earth science, don't forget to like this video, subscribe, and tap the notification bell so you never miss a moment of geological discovery. Ready? Let's get started. So, what are divergent plate boundaries? Imagine Earth's crust like a massive puzzle made of huge slabs called tectonic plates. At divergent boundaries, these plates are slowly drifting away from each other. As these plates separate, molten rock or magma from deep inside Earth's mantle rises up to fill the gap. When magma cools, it forms brand new crust, slowly building fresh ocean floor. That's why divergent boundaries are also called spreading centers, because they are constantly constructing new crust. Most divergent boundaries lie under the ocean, and they form a massive underwater mountain chain called the global Oceanic Ridge System. This ridge system is the longest topographic feature on Earth, over 65,000 kilometers long. That's almost twice the circumference of the planet. You've probably heard of some of its segments, like the Mid-Atlantic Ridge, the East Pacific Rise, and the Mid-Indian Ridge. These ridges are elevated zones on the ocean floor, rising 2 to 3 kilometers above the surrounding seafloor. But don't be fooled by the word ridge. They're not narrow like mountain peaks. They can be 1,000 to 4,000 kilometers wide. And right along their central axes, you often find deep cracks called rift valleys, clear evidence that the ocean crust is being pulled apart by tension forces. This process is called seafloor spreading. It's how the Earth constantly recycles and renews its oceanic crust. On average, new seafloor grows at about 5 centimeters per year. That's roughly the speed your fingernails grow. But some ridges like the East Pacific Rise in the Pacific Ocean spread even faster, making new ocean crust at a rapid pace. That may not sound like much, but it's enough to create entire ocean basins in under 200 million years, and that's fast on a geological timescale. But what makes these ridges stand so tall? Let's find out. It's because the crust near the ridge is hot and less dense, freshly formed from upwelling magma. As it moves away from the ridge, it cools and contracts, becoming denser and slowly sinking deeper into the ocean basin. That's why ocean depths increase with distance from the ridge. This process takes time, about 80 million years for the crust to stabilize thermally and reach its maximum thickness, which is around 100 kilometers. By then, it's been buried under layers of ocean sediment and lies far from where it was born. But the mid-ocean ridges aren't just mountains, they're alive with incredible activity. Along these ridges, you find hydrothermal vents, deep-sea chimneys that spew superheated, mineral-rich water. A well-known example is the BB hydrothermal vent field on the Mid-Cayman Spreading Center in the Caribbean. It is notable for being the world's deepest known hydrothermal vent site, located nearly 5,000 meters or 16,000 feet below the surface. This vent field features superheated, mineral-rich water spewing into the ocean and supports unique ecosystems thriving in extreme conditions. These vents support entire ecosystems where bizarre creatures like tube worms, giant clams, and strange crabs live. What's unique? They survive without sunlight by relying on bacteria that convert chemicals from the vents into energy, a process called chemosynthesis. It's like an alien world right here on Earth. Here's a fascinating fact. As magma cools and hardens into crust, tiny minerals inside it lock in the direction of Earth's magnetic field at that time. Now, Earth's magnetic field flips every few 100,000 years. This creates mirror-image paleomagnetic stripes on either side of the ridge, one of the strongest pieces of evidence for seafloor spreading and plate tectonics. And those mid-ocean ridges aren't smooth lines. Sometimes deep rift valleys split the ridge crust. This shows the crust is really being pulled apart. Mid-ocean ridges aren't continuous. They're broken into segments by fractures called transform faults. Think of these like the zipper breaks on a jacket. These faults cause shallow, sometimes strong earthquakes. So, the Earth's crust is constantly moving, breaking, and reshaping itself. Divergent boundaries aren't just underwater. Sometimes, this pulling apart happens on continents in a process called continental rifting. This is how a single landmass can split into two or more segments over millions of years. Take the East African Rift, for example. This is a classic modern-day rift zone where the African plate is slowly pulling apart. What happens during continental rifting? Mantle upwelling causes the overlying crust to bulge and stretch. The brittle crust cracks and breaks into blocks. These blocks sink and form a deep, elongated valley called a rift valley. In the East African Rift, we see active volcanism, faulting, and earthquakes. Mountains like Mount Kilimanjaro and Mount Kenya were formed by this rising magma. In rift valleys, such as the East African Rift, you not only get volcanism and earthquakes, but also dramatic surface features, deep fault valleys, escarpments, geothermal springs, and even long, linear lakes like Lake Tanganyika and Lake Malawi. If rifting continues, the valley could eventually deepen and extend to the coast, allowing seawater to flood in, just like what happened with the Red Sea when the Arabian Peninsula split from Africa. So, the East African Rift might be a preview of a new ocean in the making. While divergent boundaries generally cause shallow earthquakes, less violent than those at convergent boundaries, they teach scientists a lot about how Earth's crust behaves under tension. You also get fascinating structures like triple junctions, places where three plates meet. A great example of a triple junction is the East African Rift Triple Junction, where the African, Arabian, and Somali plates pull apart. Another interesting feature is the Oligocene, a failed rift that started to form but didn't fully develop into an ocean. The Benue Trough in Nigeria is an example of a failed rift arm or oligocene, formed during the breakup of Pangaea and the opening of the South Atlantic Ocean. These tell us about past tectonic activity and often become resource-rich basins. Before we wrap up, here are some quick facts. The volcanic rock formed at divergent boundaries is mostly basalt, which is rich in iron and magnesium and flows easily to build ocean crust. Mid-ocean ridges cover about 23% of Earth's surface, more than twice the area of all the continents combined. If you found this video helpful or learned something new, do me a favor, hit that like button, subscribe, and share this with a fellow Earth science nerd. Which part blew your mind the most? Let me know in the comments. And stick around, we've got more plate tectonics and Earth mysteries coming up next. Thanks for watching and see you in the next video.